Okay, so yesterday we worked on different ways that we could represent decimals. Today we're going to work with representing decimals in expanded form. So that is not one of the ways that we worked on in the previous lesson. So we're going to work on that today. So our objective is to be able to, we want to be able to complete and identify expanded form for decimals. And we want to understand the place value system as we go through our lesson. So you're going to write the following in expanded form. So expanded, remember, means like stretching out, making it bigger. So I look at each place value and I just add them. So I have 300 plus 10 plus 7. There's one way I could do expanded form. This one I'll do a little different. So I could do 6 times 100 because the 6 is in the hundreds place. And I don't have to say plus 0 or do anything with that. Then I would just say plus 8 times 1 because there's an 8 in the ones place. And that would be another example of expanded form. On this one, a little bit longer here, so I could say 1,000 plus 900 plus 50 plus 6. And then we'll look at the next ones here, the level 3. We'll look at one, and you can do the other one for level 2. Okay, so you can see there I could say 1 times 10,000 because the 1 is in the 10,000s place. There's nothing in the thousands because of the 0. And then I could say parentheses. I see a 9 in the thousands, so I could say 9 times 1,000. Plus there's a 4 in the tens place, so I could say times 10. And then there's a 1 in the ones place, so I'd say 1 times 1. And then again, you can do the next one on your own, see how you're doing to practice that. Okay, so just some vocabulary review. A digit, when we say that, that's one of the number symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 in the standard base 10 system. So a digit is just any number 0 through 9, okay, when it's all by itself. Expanded form, a way of writing a number is the sum of the values of each digit. For example, in expanded form, 356 is written as 300 plus 50 plus 6. You can compare standard form to expanded form, and standard form is when the number is written the way it's supposed to. Okay, and standard notation is the same as standard form. So it's frustrating. Sometimes they exchange the language there, but standard form and standard notation are the exact same thing. Now, you are going to complete math message on math journal page 118. So go ahead and pause the video and do that now, please, before you move forward. So complete that, and then we'll look at it together. What did you notice as you added different colors of shading to your grid? So what are some things that you notice when you use different colors? So think about that. And as you look at it here, it says to shade the grid to represent 3/10. Now you may think, well, that's actually a thousandths grid. So what I could do is write an equivalent fraction. So 3/10, I could make it 300 thousandths. For me, that's easier to visualize and to shade. And so you can see with the first color here, I did 1, 2, 3 rows, each one 100. So that's 300 thousandths. Then I look at and it says add shading to the grid to show 31 hundredths or 310 thousandths. So we already have the 300. So really all we needed to do here was the 10 thousandths. So if I look here, I can see the square equals 10 thousandths. Then the last part, it says use a third color on the grid to show 312 thousandths. Well, we already did 310 thousandths, so we only have to do 2 thousandths. And you see the two little rectangles there. Each one is 1/1000. Okay, so hopefully you notice when you use the three different ones there, the differences, right? So we started with 100 thousandths, and then we got into the 10 thousandths, and then we got into the single digit side of the thousands. Okay. So what does the first square and the second color represent? So if we look at the second color that we used here, we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know that's 10 out of 1,000 total rectangles, right? So what number does the tiny rectangles shaded in the third color represent? So look at the third color. We have 1, 2. So that would represent, I'll just write it here, 2 thousands. Because that's two little rectangles out of 1,000 of them. So I'd write that as 2 thousands. And so the shading shows 3/10, 1/100th, and 2 thousandths. And when you combine those, you can make 3/12. Okay, so we did 3/10, 3/10, and then we did 1/100th is how you could look at that, and then you did 2/10. Okay, and so there's this way of writing the number is called expanded form. So you can see there, just like we would do with whole numbers, but we wrote it with place values. So expanded form shows the number broken apart by place value and shows the sum of the value of each digit. In today's lesson, you're going to extend your understanding to expanded form to decimal numbers. Remember, you've already represented whole numbers in expanded form in multiple ways as sums of whole numbers. So 400 plus 20 plus 8. As sums with place value names, so you can say 400s plus 2 10s plus 8 1s. Or you could do it in a multiplication expression, 4 times 100 plus 2 times 10 plus 8 times 1. There are also several ways to write decimals in expanded form. How would you write 312 in expanded form? Think about the examples for the whole numbers. And this is where a lot of times people get confused. So let's look here. If I wanted to do it by just adding the numbers, I could start with 0, 3/10. Then I could say 0, my decimal, and because I'm not going to report the 3 because I did there, I'm going to put a 0 in the tenths, and then I'm adding the hundredths, which is 1 in the hundredths place. And then I'm going to start with my 0, my decimal. I already reported the tenths, so I'm going to put a 0. I already reported the hundredths, so I'm going to put a 0. And then I'm going to put the 2 in the thousandths place. So that's one way that I could represent that. You must have those decimals as placeholders when you do the place values. If you don't, then it would not be correct. Okay, I could also look at it and I could say 3 times 1/10 plus, there's a 1 in the hundredths, so I could say multiply that by 100 plus a 2 in the thousandths, so I could say 2 times 1, oops, sorry, not 1. Yep, sorry, 1/1000 would be another way I could represent that. So that's two different ways that I could represent that decimal expanded form. Okay, and again, here's a whole list of them. So I could also say 3/10 plus 100th plus 2 thousandths. I could do brackets, and the brackets here, this just means, if you see this, means to multiply. Okay, I just put the brackets in place there. But that means take this and multiply by the inside. Okay, so again, 3 times 1/10 plus 1 times 1/10. So just different ways to represent it there. So again, these are usually the most confusing because of the brackets, but it means to multiply the outside by the value on the inside. The different ways to represent a value of each number shows the value of each digit in standard notation. So 3/10 plus 1/10 plus 2 thousandths. So we could use words to show place value names as well as fractions. So different ways to represent each value of a number there. So again, you can see you could multiply it by its decimal form. You could multiply it by its fraction form. You could use brackets or you could use parentheses. Okay, the fraction and the decimal can be used interchangeably to indicate place value. So this is the exact same thing as 1/10 as a fraction. So you can go back and forth with those. Think about how you would represent decimals greater than 1 in expanded form. So for example, how would you represent 1 in 2300ths? Okay, so I could say 1 times times 1, right, because it's in the ones place, plus 0.2 times, and it's in the tens place, so I could say by 1/10, plus 3 times 1/100th. Now, how would you write 7 and 53/100ths in expanded form? So let's see, 7 and 53/100ths. And again, there's multiple ways. I'll just show you one here. So I could say 7 multiplied by 1's place, plus, I have a 5 in the tens place. Let's say 0 decimal 1 plus 3, and it's multiplied by the hundredths place, so I put a 0 in the ones, 0 in the tens since I already used that, and I go to the thousandths and I would put 1 for 1,000. And you could write those as fractions, you could write it in number word form. There's several different methods you could use for that. Okay, so at this point you want to pause the video and you want to make sure you get your math journal and you complete page 118. After you've completed that, then come back to the video. So if we look here at the examples, it says, gives you 3 different categories or versions of expanded form that you need to use. So you can see the first one here, how they did just the decimals and added them. Here they multiply by the place values in decimal form. Okay, so the sum of the decimals in standard notation, sum of multiplication expressions, but they want you to use decimals. Here's the difference with this one. They want you to use fractions. Okay? So as we look at the fraction one especially, we see 1/10, 1 over 10, 1 over 100, it's 1/100th, and then 1,000. So let's look here. So you can see on this one here, they did 2 because it's a whole number, plus 4/10ths, plus 7/10ths, or hundredths. So the big thing is here, notice they put a 0 in the tenths because it's in the hundredths place. And then here they put 2 zeros because it's in the thousandths place. So the tenths and the hundredths have already been accounted for there. Okay, same thing. They took those same number and worked it out over here. And you can see they did tenths, hundredths, thousandths. And again, these zeros are important in front of it because that is like a placeholder. It tells you to move to the next place value. And then again, you can see here they did it in fraction form. Okay. And so now, and again, at this point, as you look through here, you should be just checking your answers. This will be a great time as you look through here. If there's any you missed, to go ahead and mark those. So when we have small group time, whole group math lesson in Google Meet, you can talk to your teacher and ask questions or any examples or help you need with that. So that'd be a great time to do that, to be prepared. And you can see on here in the last one, they give you a little bit of challenge. They want you to go backwards and they decompose the number and they want you to build it back up. Okay, so I could look at that and say, okay, 6/10ths. So there's a 6 in the tenths place, there's a 3 in hundredths, and there's a 7 in the thousandths place. So you will continue to practice representing decimals in expanded form. You will draw 3 number cards and use to create decimal on place value map. Okay, so you could just pick 3 numbers there. As you can see, so we got 439 thousandths, right? We wrote an expanded form, so you can see there's 1 row, 2 rows, 3 rows, 4 rows of hundreds. So that gives us our 4/10ths or 400 in the 439. And then you can see we colored in 3 whole squares of 10. So that would give us our 300ths or 30 thousandths. And then we colored in 9 rectangles, so that would be 9 thousandths. Okay. So if you draw the following cards are drawn, how would you write those in expanded form? So how will a 0 card affect the look of your representation on the graph? Okay, so think about these zeros here. Is this going to make it smaller or larger? Well, if I look at this one, 42/100ths, or sorry, 42 thousandths, and there's a 0 in the tenths place, is that going to make a difference? What do you think that might do to your graph? And then you see the 0 here, so 590 thousandths. Well, if I'm comparing these two, and I see a 0 here and a 5 here, I know this one's going to be greater, right? This one's going to be greater. And that 0 at the end makes it 590 thousandths. The 0 at the beginning here, it makes this only 42 thousandths. So this one's going to be less when I compare those two. So I'm going to be doing more shading on the thousandths grid than I would with this one. Okay. So on this part here, you do not have the Math Masters page, but you can, if you want to practice, just pulling cards and writing them in expanded form. That would be a great thing to do. Okay. And fraction capture. This is a game you would normally play, just comparing decimals here. Obviously, you don't have the things at home. You might be able to find some stuff on Connect Ed with that. Okay. All right.